Introducing Artificial Intelligence in Healthcare, an online conference hosting prominent pioneering doctors along with latest technology experts. It is an online conference happening globally on the 21st of August to bring about and actualize the brightest ideas that can build the future of the healthcare ecosystem.
It will be a platform for the coming together and collaboration of medical institutions with technologists, encompassing all the potential that artificial intelligence brings and all the avenues where it is already adding value with its many applications in the domain of healthcare.
The conference will explore various applications of artificial intelligence and emerging technologies in early screening, disease classification, and various applications. In dermatology, classifying different types of lesions through smartphone cameras. In oncology, classifying and grading tumors and also localizing scans to the area of concern. In physiotherapy, AI finds its applications for gait analysis and estimation of the human pose in sport and movement applications. While in neurology, applications may be focused on classifying dementia, epilepsy prediction, and early classification of Alzheimer's. In cardiology, heart arrhythmia with ECG through fitness variables. In ophthalmology, classifying diabetic retinopathy through retina scans.
And in epidemiology, identifying the trends and patterns of the spread of disease, mapping it geographically, and predicting data points of the spread, and later predicting herd immunity and pathology diagnostics. Applications in doctor workflow assisting tools, such as in cleaning data of radiology scans, and organization and communication coordination tools. Development of patient helping tools through data collection and digitization. Automation apps and virtual assistants helping the patients through the process can all be explored through artificial intelligence.
So hello everyone. Welcome to Artificial Intelligence in Healthcare, our virtual conference. I'm Dr. Vishu Gupta, Head of Research at TensaX Innovation Lab. And on behalf of the TensaX team, it's my absolute pleasure to welcome all of our participants and eminent speakers that are joining us today. And we'll started with just 1 second. If everybody could please just mute your mics, that would be great so that we don't have any over. Thank you very much, everyone. So yeah, like I said, welcome everyone. What we'll do, our goal here today is to explore how artificial intelligence can play a significant role in, in a lot of the applications of healthcare. So we are being joined by, prominent figures and eminent speakers today. We have with us today Professor Rajesh Kumar, who's a professor at the Department of Electrical Engineering at MNIT Jaipur. Dr. Vikram Bhura, he's the Chief Interventional Neurologist at Rajasthan Hospital in Jaipur. Mr. Aryan Singh, Chief Technology Officer at TensaX Innovation Lab. Dr. Apoorva Singh, Director and Consultant Dermatologist at Aesthetic Dermatology Clinic in Delhi and Ghaziabad. Dr. Bhanwar Ranwa, Head of Department of Cardiology at the Government Medical College in Kota, Rajasthan. And Dr. Ravi Ranjan Kumar Neeraj, who is an assistant professor at Amity School of Biotech at Amity University, Rajasthan. And so with that, let's get started with our very first presentation, which is being given by Mr. Aryan Singh, Chief Technology Officer at TensaX Innovation Lab. Mr. Aryan Singh, can we all have your screen, please? Yes. We'll just wait 1 second.
Hello all and welcome to Artificial Intelligence in Healthcare. Artificial intelligence in healthcare and its application has been increasingly growing. And we all can see that since 2018, it's been on the rise in terms of its practical applications and applied applications in different sectors within healthcare. And there's a reason behind that. That reason is, I have a few stories for you here. Look at this first one. A fitness wearable, Apple Watch, saves the life of a 61-year-old man in Indore. This particular application is electrocardiograph, it's under cardiology, and the watch has a sensor, and the watch uses a machine learning model to look at the data of the electrocardiograph sensor and predicts whether the person has an arrhythmia in their heartbeat pattern or its sinus. So because of this, a person's life was saved. And here we see another example. This fitness wearable saves the life of another person. And what they did here was they had a labeled data set of all of the motion sensors, which was the accelerometer and other sensors. And then they had a labeled data set of whether the person had a fall or it was not. And then the watch is continuously monitoring all of the data, and it's looking at whether the person has fallen down or not. And when it detects that the person has fallen down, this alert gets activated and it calls emergency services. Since its conception from about 2014 to 2021, there has been an 11 times increase in the amount of applied applications of artificial intelligence in the healthcare sector. And there's a reason behind that. That reason is because of all the efficiency that it brings in, because of all the increases in productivity, all the increases in patient experience, all the enhancements in the ways models can be deployed to end patients and how they can be helped in different ways. Because of all these reasons, there has been such an increase in artificial intelligence adoption. And we will notice that this trend is about to stay like that, and it will stay like that from here on till the future. And to get into it, let's first define what artificial intelligence is. So we have intelligence, which is human intelligence, and it's our ability to learn and understand and make sense of our environment. Artificial intelligence is the ability of machines to mimic the same, to perform tasks in their environment and do those tasks well. The applications of AI in healthcare are endless. We can have doctor helping tools. We can have tools that help doctors in diagnosis, that assist them in diagnosis, help them in their workflows, whether it be cleaning data or any of their workflow in terms of management and orchestration. There can be patient helping models, that can be models deployed on the user's fitness wearables as well as their mobile phones. They can take care and monitor the patient, and then also manage the connection between the patient and the doctor. And largely there can be management and organization tools that help digitize the data and do a lot of tasks on the data and generate insights from them and manage the communication between patients and doctors. And there are many applications within all the different sectors and departments of healthcare as well. Look at all of these. In Neurology, Radiology, in drug discovery, these are all newspaper headlines, and these tools are starting to be built, and they're going to be everywhere in the time that's about to come. If you talk of sector by sector applications of artificial intelligence, we have if you talk of drug discovery, we all know that it takes a lot of time for compounds to be filtered out and the tests to be run, and for that compound to be launched as a medicine that's approved and everything. And that involves the discovery of a lot of different compounds. And we have all of these different rules that we are learning, and then we are trying all the combinations out, and then we're making a compound that then works. So we can use machine learning, and these machine learning models can memorize all of these rules, and then they can generate compounds for us. We have one such example. This is AlphaFold. It predicts protein fold patterns, and it helps in generating all of these combinations that help in drug discovery. So we can use machines to their advantage, and this way we can have machines do the repetitive parts so that our tasks get easier, and overall in the industry it gets easier for us. So when such models would be applied, right now people are experimenting on them. It's going to shorten the timeline at which these medicines come out. Also, imagine personalized medicine. a patient has very typical conditions and their condition is suited to them only. We can have personalized medicine just because of how faster it is to do these tasks because of these algorithms. And this is how we predict that it's going to be when it's going to see its application practically. In neurology, we can predict all Alzheimer's and other different conditions. We can predict dementia based on speech. In dermatology, I'm sure Dr. Apoorva would have a lot more data on this, but we can have models deployed on users' smartphones that take care of all the different patterns and lesions that are forming on their skin. And then we can later connect, these apps can later connect them to doctors directly. There are very many applications, and a few of them we will talk about today. In cardiology, one example we talked of, and there are others monitoring other parameters as well, and we can predict conditions based on the results of these parameters. In radiology, we can use computer vision to clear out scans. We can localize scans to a particular region, which is the area of the concern of that particular case. We can help doctors in minimizing the amount of time it takes to process a scan, minimize and enhance the quality of scans by reducing noise, and help in diagnosis, because these models can look at thousands and millions of images and then take care of all the different features and cases that there may arise, and help doctors and assist them and give them an extra source of an additional side-by-side companion that helps them give additional data so that they can their tasks get easier. In physiotherapy, we have gait analysis, and we also have AI-powered prosthesis. When a person has diabetes, their retina degrades, and we can classify that. So we made one such model wherein we made these green and infrared filters, and we worked with Dr. Maya Hara and Dr. Vishal. And our model had state-of-the-art efficiency and state-of-the-art accuracy in predicting diabetic retinopathy. And this can be done through retinal scans. If we talk about a few ideas and the things that we can have personalized medicine in healthcare. We can have AI digitize data for us and keep those records, and then we can predict what conditions a patient might have. Right now, we're not storing data and we're not running large-scale data analytics on what would lead to certain patterns. Let's say pain in the left hand and then pain in the chest. Then the person is recommended to a cardiologist. So based on recursive patterns, we can predict a lot of things. So with technology, we can create something known as a health ID, and that can be kept under a blockchain using smart contracts, so that becomes an immutable ledger, so that security is no concern, and it becomes anonymous and it becomes immutable. Then we can do all of these data analytics and pattern recognition programs powered by machine learning and artificial intelligence and recognize a lot of things. We can match patients and doctors based on the types of conditions and cases and the different conditions that come about. We can have patient helping tools. We can have digitized and automated step-by-step data collection, an app that has a virtual assistant that talks to patients and takes care of them and guides them through the process and speaks to them in their language. It manages the orchestration and the communication between the doctors. We can have, because of this, we can have, if we apply this, we can have faster turnarounds. We can have we can give patients a better experience. We can have better scheduling, and we can have these AI models, some that we talked about in cardiology, in dermatology and others. I'm sure there are so many that can run on devices that patients already have and then predict a lot of things. We can have early screening and early detection of a lot of diseases before they even develop to their advanced stages. We can have doctor helping tools. We can have tools that help doctors in digitizing patient data, that assist them in diagnosis, that models that take care of doctors' repetitive tasks. We can have we'll talk about them later during the presentation as well. And we can have different models that follow up and catch up with patients so that everything is connected. And as we're talking about data digitization, all of the reports, no matter what the condition is of the reports, we can digitize them with artificial intelligence. And this is TensaX Innovation Lab. We have been making a lot of models, and we like to explore all of the possibilities that can happen. And we'd like to build those things over here in our space, in our country, and have it done. We built the world's highest performing facial micro expression recognition. That's still the world's highest performing facial micro expression recognition model in our lab here. And this is our lab. And let's explore how we can develop end user applications, applications that help patients, applications that help doctors, and applications that help medical institutions, and how an ecosystem of all of these coming together, and how we can make models to help in all of these different silos. And I think to further get onto that, this is from our side, we need data, and we would need all of your experience. You've been in this space for so many years, and we'd like to, and we love that you work with us, you tell us how your workflow is, how your process is, and then we'd like to, sit together and talk about what all models we can build, where all we can apply technology, in machine learning, where all we can apply computer vision, where all we can apply prediction models, classification models, where all we can apply natural language, wherein we can apply a lot of models that, that would come about. And after such a discussion, it would be great to talk about all of the possibilities, and then let's start to work together and build them. And from your side, you let us know what all you need. And that was my presentation. And now let's get started and let's get further on in this event, in this conference today, and over to other speakers. Thank you.
Thank you so much, Aryan. We have an interesting idea already in our chat box. So with regards to that, what I'm going to say is please make sure if you have any questions or, concerns with, to discuss with our panelists, just please make sure to put them in the chat box. Now, the comment that we have is that we can make a common global platform to interact with each other. This is from Mr. Amit Mittal. And this is a great idea that we can perhaps, explore down the road, where, different medical sectors and technologies can perhaps interact, globally like that.
Let's start from here. And, I think it can be more specific than GitHub. GitHub is a more generalized platform, wherein here all of us, and let's indulge all of the doctors in our network, and we can start to work towards this from our side. And we can be more specific and more targeted. GitHub is more generalized. We can be more specific and more targeted. Yeah.
Yes, so we already have a great start to our conference today. So what we're going to do is we're going to move on to our next speaker, which is Professor Rajesh Kumar. And it is honestly an honor to introduce Professor Rajesh Kumar. Professor Rajesh is my teacher, really. So with his degree in electrical engineering from the National Institute of Technology, Kurukshetra in India, in '94, degree in power systems from the Malviya National Institute of Technology, Jaipur, Rajasthan, and his PhD degree in intelligent systems from the University of Rajasthan in 2005. Now, since 1995, he has been a faculty member with the Department of Electrical Engineering at MNIT Jaipur, and he is currently associated as a professor there. He was also a postdoctoral research fellow with the Department of Electrical and Computer Engineering at National University of Singapore from 2009 to 2011. Now, his research focuses are quite varied, including theory and practice of intelligent systems, computational intelligence and analytics, electric transportation, grid robotics, and healthcare. So, sir, I would request you to please share your screen and share your thoughts with us.
Good afternoon, Dr. Vishu. I think I'm audible to everyone.
Yes, sir.
Give me permission to share my screen. It is disabled currently.
Just 1 second, sir. We'll just get to that. Sir, it should allow you to share the screen now. So are you able to share your screen now?
Yeah, now I can share. So how much time I have, because my time is already taken?
No, sir, you have, sir, as much as
Okay,
you would like to
okay,
discuss.
okay. So, fine. So, is it visible?
Yes.
Yes.
Yeah,
It's
okay. Thank you. So, the earlier speaker has talked about various aspects of AI in healthcare, and I try to now summarize on a one screenshot, like where means like people have used AI in healthcare, and they are going to implement it. Thanks to this buzzword AI and ML, and thanks to your computer science and electronics material people who developed fast computing machines. Thanks in a sense, they popularize again the basic mathematics. So it is nothing more than that. But we are using that mathematics in a different form to connect the data, to connect the dot and try to find out the interrelation between the data about the patterns which we have. And these are the few areas where it is being tested. In some areas, it is already being implemented and accepted by the community, taking from speech automation to nursing to support the hospital administration. Yeah, data security is a very critical, the costliest thing I expect in the future, and that is the data. So health data is very important, not only for the patient, but yeah, there are many uh, uh, people involved in it, starting with the patient, the doctors, the insurance people, and so on. Imaging will be, yes, nowadays it is very popular. Then diagnosis, digital consultation, and then a lot of more things are there. Usually we have data either in the form of or medical data in the form of an image, or in terms of some numeric terms which calculated from various resources. And then what we try to do, we try to just to find out what are the few things which can be directly analyzed and summarized. But we are on the research side, we try to find out what are the other relations between the hidden patterns which are already there. Just to give you some like how people are implementing it and then they are doing it. sharing some of the work of my lab, Raman lab from MNIT Jaipur. So just giving, I don't know, yeah, some simple case studies. A lot of things can be done. This one is very popular research. Most of the academia people, they are doing, because this data is available on the free domain. So normally what they do is they take the data, and the diseases, yes, medical doctors are already there who put more light on it. But this one is a very challenging thing, is basically how to distinguish these images. And there is nothing like a replacement of anything, like it will not replacement. It's like a support to the doctors, because they are very busy, they have less time for each individual patient. So these things may help them in making decisions, reaching to the decisions very fast. So the proper way of doing the things is always, you'll find like this. You load your pre-trained models or trained on certain data. Training of models is nothing in terms of mathematics. We talk about, we are setting certain parameters so that we can develop a correlation between your input and output patterns, and then we look for the new batches, and then again train it, and then we look for certain matrices, like how accurate is my model, how precise is my model. We take about recall, F1 score, so that we can have a confidence on our model. And then we can say that, okay, this model is good enough to make certain decision. Now we pass the new data, and then we can have certain results. So when we do it, these are the things which people, engineering people, they call it machine learning or AI. You can see here on your screen right now, you have a lot of models which are popular, developed by various researchers, connecting in your mathematical equations in various forms. And then they try to find out, okay, check out these parameters, and then they can make a certain decision that, okay, this model is more accurate, you should go for it. So this one is just to give an idea that, okay, how we means most of the people who are working in the medical and health, they try to connect it. Okay, and then they try to plot it to justify the things so about their models there. Okay, so these are the various approaches how they justified it. Okay, which model is good, why it is good, and try to conclude from there. Another case study. So earlier one is from another set type of problem. This one is another major problem. One of students, he worked on it in the lab, that is musculoskeletal disorder. This one, MSD, is very popular nowadays, and the WHO is putting a lot of things on it to identify all these things. So the flow is again the same. You capture the videos, and that is the data collection, and then apply certain kind of a mathematical formulation so that we can extract the meaningful data from it. So here is, suppose how a person is sitting, and then we try to calculate the angle, and then we use certain kind of a combination of mathematical formulation so that we can end up whether the person is normal or he's suffering of certain things. So this is how people are doing. These are the certainty, the pose is there. There are various joints there. From these joints, we try to find out the angle. What is the angle there? And these are the video frames, and then you can see there. I go to the next slide, I will give you better picture. So the person is sitting here, and in the posture, we can have different angles. These, once we have these angles, then we use certain kind of mathematical formulation that, okay, and how much is the accuracy in finding these angles and all these things. And then, yeah, we take the inputs from those people. Are they suffering or not suffering? Also, we take the input from the doctors that, okay, what is the issue and that one. And then finally, again, we go for all those parameters to say that, okay, my model is there or not. It will give you a certain kind of information, basically, that, okay, once my model is trained, and if I take a new input to it, how accurately it give me the calculations. And once we have those, we can have certain kind of opinion about the thing, that whether the person is suffering or not. Very obviously, this must be, say it must be again confirmed by the doctors, because they have more experience and they are in healthcare. Many times we are making these mistakes that, okay, my algorithm is there and just it's a replacement of anything. Don't go for it. There are many other issues. Maybe later on during this conference, people talk about it. This one is another work which is very interesting to analyze. We are studying, making some studies on it. This one is basically how we move, and this one is funded by the government of India to analyze the human gait. So gait means how we move, and a lot of hidden signatures in it. It not only give you the problems you are facing, it may be having some predictions in future that what kind of issues you may have. Even some studies are published that you can predict whether a person is diabetic or not, even from the gaits. You can think of many other things also there. Applications are enormous. You can see on your screen now. It can be rehabilitation, it can be in sports, it can be in robotics, it can be people, old age people, just analyzing their whether how they are feeling it. A lot of things can be analyzed from there. It has a relation in identifying a person, authenticity of a person, nature of a person, and some more research towards what a person is working on or looking for. The process is again very simple. I'm just sharing with you. Just get some videos there, and we are interested in finding these angles because these will give you certain kind of a signature of a person there. So the process is a person is moving from video, we move to video frames, and then you go for a pre-processing. These are the certain these are the approaches which we use to remove the unnecessary information from our from the data or from the images we have, and then we try to identify some markers. Finally, we have signatures of the gait, and then we can use these signatures for rest of our purpose. It can be for the security reasons, it can be for healthcare reasons, it can be for rehabilitation, and likewise. So the extension of that one is human activity. So you can recognize it, what a person is doing, or you can make your machine automated to make it understand that, okay, what is exercise done by a person. Another one is basically another work which we are doing is basically connected with osteoarthritis, and where instead of taking images of your inside images of your bones, and likewise we are more interested in getting muscles activity signals, and from there we try to identify that what is happening inside the body. So this one is the setup. You can see here getting the sensor signals, and then we are rectifying these signals, and from there we try to connect it. The process, if you see, it is always same, like subject, you have data, you can see here the data in terms of signals. It may be in terms of some numeric numbers, it can be in terms of images. You go for some processing technique, feature extraction. You can avoid it, you can go for deep learning approaches. So those are the different approaches, and then we approach these mathematical combinations of variables to identify what is the activity or what is the probability. And then we come out with again all those parameters to say that, okay, which method is good for it or not. Okay, so and as we move into the things become more and more complex, and this one is one of the major problem which we face in healthcare, that is basically imbalanced data. Most of time when you collect the data, we have a lot of data which is related to the good or healthy people, and very less data which is for a suffered person, or a person is suffering from certain disease. And then if you want to train your models, you'll see that your data, imbalanced data, and there are chances of biasing in those models, which may lead to wrong diagnosis later on. So such type of issues are there, and mathematically we try to find out what are the possible solutions to identify, to make the data balance and to make our model more and more accurate. So these are the few approaches people are using. One of them is you are using this smart oversampling, and then from there try to find it out. I'm not going to the algorithms right now because this one is just an introductory part of it. So smart give oversampling, undersampling. These are the certain issues which are related to the things when we handle a medical data, and when we are using those data for to train our models, which we need to take care. So these things are very common things are there, and this is the team which is working on the healthcare, the old team and the new team also there. So yeah, that's all from my side. I try to connect few things related to the healthcare and healthcare and machine learning or machine intelligent or intelligent system. That's all from my side. Yeah, thank you very much. If you have queries, we can have a certain questions. So if you have, I'll try to answer your questions.
Thank you so much, sir. If anyone has any questions for Professor Rajesh or for any of our panelists, please feel free to add them in the chat box. And if you would like to kind of think about those questions and then get back to us, we'll be having a panel discussion towards in a little while. So we can address those questions from your side at that point as well.
Okay, that will be great idea. Like, so let's move on because I think we are in a delay. We are lagging in the time space. So thank you very much. Let's move further. Thank you.
Thank you, sir. So our next speaker is Dr. Vikram Bhura. He is the Chief Interventional Neurologist at Rajasthan Hospital in Jaipur. He has finished his MBBS from Mumbai, his MD in General Medicine from Udaipur, and he has a DM in Neurology. He has also done a fellowship in Interventional Neurology and Stroke at the excuse me, at the Mazumdar Shaw Medical Center from Narayana Health City in Bengaluru. And he has also obtained a neurointervention observership from the Mount Sinai Hospital in New York. He's had an illustrious career working at the R&T Medical College in Udaipur, GB Pant Hospital in New Delhi, the Metro Mass Hospital in Jaipur, then Eternal Hospital, EHCC in Jaipur, and now currently at, and also at CK Birla Hospitals in Jaipur as well. And now we are currently at Rajasthan Hospital in Jaipur. So welcome to our session.
Yeah, good afternoon, everyone. Thank you for giving me this opportunity to discuss about AI in healthcare. I believe till date, I used to just read about it in our journals. And now because of this presentation, I got to read about it a lot. So I think I got to know more about the concept because of this presentation. Although we used to think that we need these things, but we were not aware, or rather I was not aware that where I can actually use it. But now I'm more aware about the things. So I believe we are already running late and I won't take much of your time. So I'll start my presentation. So I'll be presenting a few scenarios where I think how machine learning or AI can help doctors as well as population at large to get good advantage and recognition of their ailments and getting better treatment. So there is a person who has had a sudden difficulty speaking. He's living in a village and he doesn't have any easy access to specialists. Local doctors, although they are well trained, but they are not enough trained to diagnose a disease which has just led to some speech difficulty. So now what he can do, either he can just wait for the disease to progress so that the local doctor can diagnose it, or he has to go a long distance away and remain confused which doctor he should see, whether a ENT specialist will help, whether a neurologist will help, physician will help, or what. So here the role of AI comes in. So now we have a few programs where a person can just call a number, speak to it, and based on that speech assessment, AI will help pick up a probable diagnosis for him so that he'll be better able to understand what his possible problem is and which doctor he should see so that he can reach a proper doctor in proper time. Talking about speech difficulties, and I being an interventional neurologist, the most common reason for the same which I find are strokes. Time is brain is the important concept in stroke. Why is it important? Because the major reason for strokes is blood vessel blockage because of some thrombus, which is called an ischemic stroke. 90% of strokes are because of that. The common word which we use in our scenario for strokes is lakwa. Usually a patient will develop either speech difficulty or one side of body becoming weak or some vision impairment, balance impairment. Either of those or together of those can be sudden onset. It can be a stroke. Why time is brain? Because with each second, the blockage continues, additional 30,000 neurons will permanently die off. That is almost equivalent to half an hour of our aging process. So suppose I am off duty, I am just walking around in a mall, or I am just about to sleep. So there I just get a message on my app on a phone, and that makes me aware that there is a potential large vessel occlusion patient. What is large vessel occlusion? About 30% of stroke patients will have occlusion in major vessel of their brain, where now we can just go in, take out the clot, and patient will instantly become better. Why AI is needed in this field? Because we now have availability of CT scan at even smaller cities, towns, and villages, but there is no one to assess those images. So that is where AI comes in. It will just analyze the image and let you know within seconds. Even before a doctor has seen the images, you will get to know on your phone that there is a potential such patient. We can just try to triage the patient as early as possible and give him the advantage of mechanical thrombectomy, which is one of the means magical treatment for stroke patients. There are a few AIs already working on this model. Their names are, I have mentioned here, AI Doc, Avixenia, Brainomics, Rapid AI, and VizAI. As the time has progressed, they have now moved on to even hemorrhagic strokes where aneurysms can be picked up, abnormal vascular malformations can be picked up as early as possible, and we can give those patients a chance at better life. Beyond strokes, so now we all know that smartwatches are the thing of the day. Everyone has a smartwatch on his wrist, and it is almost like a mini computer with all AI capabilities as the time progresses. We keep on reading news in papers nowadays that Apple watches help someone, some other watches help someone. So now they have automatic fall detection. You can detect irregular heart rhythm. You can detect even sleep disorders. These are a few things which, because of AI, now we can diagnose with quite certainty. Earlier, a patient would come with just a history of fall and no one would be aware what is happening. And now, because of this ongoing assessment of his heart rhythm, we can just find out whether the heart rhythm was irregular at that time. If a person has just fallen with no one around to take care of him, the AI can just alert the emergency staff nearby or some emergency contact of the patient. So this is how a simple watch on our wrist is helping with the help of AI. Beyond that, easier access to investigation analysis. I believe most of this has been covered by the previous two speakers, but I'll just let you know how we are finding it useful. We have healthcare workers, but we are not close to the ratio which is required for efficient services or good approach for population at large. Even if we have machines to do the test, we don't have doctors to get the reporting done in times. The tests such as CT scan, MRI, electroencephalogram, and other electrophysiological tests, these can be done easily, but the reporting takes a lot of time. Sometimes only tests are done, but the reports are not reliable also. So this is where again AI comes in. Results are just transferred electronically to a person to see. Even if a person is unable to see, the AI will pick up the possible abnormalities and we can reconfirm them with the clinicians to whether the problems are persisting, and then patient can easily be diagnosed and treated. Going a step further from this electrophysiological analysis, the thing of the day is brain-computer interface. It is coming up big. Even Elon Musk has started his company into this field. So what is brain-computer interface? Based on those electrophysiological tests such as EEG, we give a feedback to the machine that the person is thinking this, how the electrical activity will be, and what is the possible analysis. How that helps. So we have a lot of patients who are disabled. That disability can be because of early aging. That disability can be of some neurodegenerative disease or stroke patients, some trauma patients who have become disabled. So in future, we hope that we can just connect them to some sort of non-invasive interface, which will assess their electrical activity, analyze what they are thinking, and try to help patient to do that activity with the help of some exoskeleton or some other machine. So we hope that in future, even medicine becomes better. We have less number of disabled patients, but even if there will be some disabled patients with time, so the brain-computer interfaces will help them to live as normal a life as possible. Finally, data is the new oil. I believe that is the dictum going on in each and every field, even in medical fields. This is the term nowadays. Everyone is trying to get hand on data of patients, be that of clinical nature, be that of their treatment part. So in India, we have a lot of patients, we have a lot of doctors, but the bad part of that is doctors doesn't have enough time to electronically record their data. If they cannot record it electronically, assessment becomes even bad. So this is where AI again comes in. We can just put in some keywords for a patient. It can store it electronically, and in future it can pick up some patterns out of it to diagnose patients easily. It can pick up a few drugs which can maybe of idiosyncratically detected that this may be useful in this disease which was never known. With the present pandemic going on, I believe electronical healthcare parts and the AI has come up big. Now we know how and why it is needed. Let's hope we don't face such pandemics in future, but obviously it has given us an advantage how now doctors have moved on to using the electronical data assessment. And in future, we may be able to give good output from that data to get a good idea about the disease profiles, the treatment profiles in our setup. Till date, we are using the European or US or North American data to make guidelines, to make treatment protocols for even Indians or Asian population. We have a lot of patients, we have a lot of data, but no one to assess it. So that is where I believe AI will come in large. So I believe I have come to the end of my discussion. Almost everyone will be discussing the same thing, I believe. So let us see what others have to say. And if there is any question, I would be happy to answer.
Does anyone have any questions?
I believe I was audible. I hope.
Yes, sir, you were audible. We're just, I think we have a question coming in. Okay, I think our questioner is not audible right now.
Okay.
So okay, I have
so maybe.
Sir?
Hello?
Yeah.
I have another question.
Sure.
So how do you think we can get started? In your practice, what types of data do you deal with and what types of models do you think we can start making?
So I deal with stroke patients. I deal with a lot of neurological patients who have with headaches, and the one with acute emergencies. Other than that, chronic diseases such as dementia, such as neck or back pain. So these are something, neck and back pain have come up big, I believe, because of the use of phone or screens a lot. So if we can pick up based on AI, what is the major problem, whether we can give patients better guideline about their posture. So that is something AI can help in. Regarding strokes, we can always put in the data at some center database. AI can assess them, find out the possible etiologies based on their almost, I think 1 out of 4 strokes are among those who have had earlier strokes. So obviously we have been unable to give them good protection. So if we can analyze their data, if AI can help us find out what are the possible shortcomings in their treatment, we can pick up ideas from that, put that in work on the patients in future, and maybe reduce at least recurrent strokes. Even if we can do that, that will be a big step forward. Among headaches, we are still quite short to find out what are the likely reasons. So maybe we can dig into the history of each and every patient based with the help of AI, find out possible reasons for those patients and give them good treatment in future. So these are a few things which I believe that we can help with the help of AI.
That's great. So, and let's meet after the event and talk about these in detail and how we can get started. If something makes sense, take these and put them into practice. We have another question. How can we make AI-based medical system to people in general? And are these projects very costly? I think when we talk of a general medical system, we're talking of in the very first phase having something like a health ID that's secured by blockchain, and then using machine learning and pattern recognition on that, and then making models from that, like we talked about earlier. I think that could be something which helps all of the people in general.
Yeah. So I just had a patient today. He is a tea vendor by his occupation, but he has invested a lot in, I believe, cryptocurrency. So today he was the one who gave me this idea that the medical records should be on blockchain, and that way we can give all the data together of a patient to a doctor, and he can better analyze it. So call it a chance that today our team conference also.
So that sounds actually perfect timing in my opinion.
Yeah.
So thank you so much, sir. If we have any other questions for sir and for our other speakers, we'll address those in the panel discussion. If that's okay, sir.
Yeah, definitely.
Okay, great. And so we have our next speaker with us. This is Dr. Ravi Ranjan Kumar Neeraj from MNIT University. He is currently assistant professor there in the MNIT School of Biotechnology. And sir, am I audible to you?
Yes, Dr. Vishu, you are audible to me.
Great, great, sir. So just a little bit about Dr. Neeraj. He has finished his PhD in bioinformatics from Maharshi Dayanand University in Rohtak, and his Master of Science in Biotechnology from Gwalior. He's had a wonderful, work experience. He's worked at the State Key Laboratory of Pulp and Paper Engineering in South China University. And he's also worked as assistant professor at Dr. Bilal Institute of Biotech in Jaipur, India. And with his current position, he's exploring different research areas with pathology and biotechnology as well. So, sir, over to you.
Thank you, Dr. Vishu. May I share my screen?
Yes, we can. So your screen is. Your screen is visible, sir.
Okay, my screen is visible to you.
Yes.
So, very good afternoon to all of you. Myself, Ravi. And first of all, I would like to thank the organizers who organized such a wonderful talk on artificial intelligence in healthcare, where artificial intelligence uh, have immense opportunities and immense problem solving, uh, power in the field of healthcare industry, right? So I will not take much of time because many of the doctors already given their talk and they well explained applications of artificial intelligence, rather the possibilities of artificial intelligence in healthcare industry. I will just quote a few of the examples that really I am working with that approach. So uh, artificial intelligence, machine learning, and deep learning, both three are interconnected, and we can say we cannot you know do anything in artificial intelligence without machine learning and deep learning. I think all of us know these things. And so we can check here, artificial intelligence has transformed industries around the world, not only the healthcare industry, even every industry from automobile industry to healthcare industry and all. Even the some of the universities and some of the biotechnology is working very well with artificial intelligence providers companies, right? So 121 health, I'm mentioning here health AI organization, company, industries who is providing AI solutions to healthcare industries or hospitals made $2.7 billion in over 200 deals. So that's a good sign for startups in AI. This is not a small amount, and maybe this seems a small amount in terms of nowadays, but believe me, AI are going to a wonderful business in coming days. And I'm not wrong if I say that every techniques and tools in bioinformatics can be replaced by artificial intelligence and machine learning. And we can see, we can't believe, in past that using AI and a smart drive can be possible. Driverless car can be possible. And we can't even believe that some of the diagnostic test is, on automation can be done using AI and machine learning approach. So, and next is the 86% of healthcare provider organizations are currently using AI technology in their, maybe instrument or their software part. They are using already artificial intelligence. So nowadays, artificial intelligence is not something that is not acceptable, is highly acceptable and is highly promising. So especially for the students and researchers, I especially suggest that they must start working on, or I can say that they start learning artificial intelligence, because the coming era is era of artificial intelligence and machine learning. Maybe it seems now that I know saying something, I'm promising something very hard, but it's true, believe me. Coming era is of artificial intelligence and machine learning. Nothing programming and no other techniques or computational approach will compete artificial intelligence and machine learning. So even in this COVID-19 pandemic, we can check many of the publications and product based on artificial intelligence. One of my collaborator in Vaccine Private Limited Australia is developed some vaccine using AI technology. I'm not saying that the complete vaccine is developed by artificial intelligence, but they used artificial intelligence for screening of their epitopes and all. And maybe they are planning to launch that vaccine in India too. and they already launched it in Saudi Arabia and all. So AI has limitless scope and opportunities. These are the few applications of AI: predictive analysis, natural language processing, and toxicology study. Toxicological study is already been used by US EPA. US EPA is an organization that gives permission for all chemical uses in USA. So they are using some tools based on AI machine learning that give you approval for use of subchemical compounds, and already approved by the government there. So it's a big thing that uses of any chemical compound approval of uses of any chemical compound is provided by AI tools and techniques. So that's a great thing, and people are started living on artificial intelligence now. And if we talk about drug target identification and ligand optimization, or some drug discovery, novel molecule discovery, uh, we all know that virtual screening is one of the part of computational aided drug designing. So AI is very frequently used in drug screening softwares and tools, and diagnostic is also one of the major area where AI is growing very fastly. Many of the companies, or you can say industries in diagnostic, like Siemens, Healthineers and all, they are using some platform that are completely well equipped with AI. Just you have to put the sample qubit, and machine will identify everything what test have to be done, and they will even uh, analyze some sort of results also, and just you have to pass on that result to the patient. Even you don't need to pass on it, they will mail it. So many of the industries are using diagnostic industries using AI. And although the list of application of AI in healthcare is very long, but the few are like robot assisted surgery process. Nowadays robots are doing some surgery. They started doing surgery using robots. Must be robot is equipped with AI. And likewise automated image diagnosis. So artificial intelligence is also used in comparative study of some of the brain image and some of the scanning images. And next, AI could detect dementia before symptom. I think one of the speaker mentioned this earlier in his talk, that AI is used to detect Alzheimer's, and this is very interesting. Although this experiment is on very small set of data set, but we need to improve the data set also.
Sir, can you hear us? No. No, network is down.
Utilization and purification is a big task, and some of the companies are working on that. They are developing some instrument that based on AI for purification and you know, crystallization process. Although in bioinformatics, AI is used for modeling of the protein structures. We are all aware about that. AI in drug discovery and development is also and I'm working on many of the projects on infectious disease and other, and I'm frequently use many of the tools based on AI that really very helpful for drug development using computational biology and all. And many of the like Novartis has partnered with IBM machine learning platform Watson. Watson is a very good platform, although it's costly now, but as technology will advance, cost of the technology go lower side. We all know that. So we have to work together to make this technology available to every common man and every, we can say, in less cost comparatively. And artificial intelligence build new antibiotic. Even few of the examples like MIT researchers used artificial intelligence for some antibiotic development and discovery. And health monitoring is also a very good example of artificial intelligence used in healthcare industries. And next is bringing intelligence to medical devices and machine. We already taken many of the examples like robotic surgery and all. So many of the medical devices and machines are using artificial intelligence, and they are uh, really doing a wonder to this healthcare sector. And these are the few examples of artificial intelligence based devices and technology, like Dexcom partner with Apple using some glucose monitor by Apple watches and all. So day by day, we encounter many of the devices based on AI. And that's all. Few things I would also add to my talk, that people are scared that one day AI will replace human intelligence. Although it is impossible, but it is not impossible. One day come, maybe artificial intelligence will give you tough competition in their field. Uh, I, I want to say that to human intelligence, because if machine will learn doing some task, then machine can really do wonder. Because the human brain have their limitation, human intelligence have limitation. Uh, so, but machine is limitless. How fast is computer? You can see how fast they can solve complex problem of any data. And before my talk, one of speaker mentioned about the personalized medicine. So yes, personalized medicine, AI, and machine learning will really change health industries, and this is good for even doctors and the researchers. So thank you all. Now, if you want to discuss anything, then welcome.
Yeah, thank you so much, sir. So we'll hold off on the questions till our panel discussion. So if you have any questions for Dr. Neeraj, please add them to the chat box, and we'll get to them in our panel discussion aspect. So our next speaker is Dr. Apoorva Singh. Welcome to the session, ma'am. Dr. Apoorva Singh has her MBBS and MD in dermatology. She is currently the director and consultant dermatologist and cosmetologist at Aesthetic Dermatology Clinic in Delhi and Ghaziabad. She has had more than 10 years of clinical experiences and has a keen interest in cosmetology procedures. She holds the membership of Indian Association of Dermatologists, Venereologists, and Leprologists, which is the IADVL, the Delhi chapter of IADVL. She is also the member of Cosmetic Dermatology Association of India, and she has attended and presented at many national level conferences and workshops. Ma'am, we welcome you to the session. Please.
Hello everyone. Thank you for this amazing platform. Now I'll be sharing my slides, just a second. Can you share my PPT, Vishu?
Yes, just 1 second.
Yeah.
Just give us 1 moment and we'll get that ready. Is it shared? First slide, please. Ma'am, it should be visible now.
Yes, it's visible. Yes. Hello, everyone. Very warm welcome to all the attendees, and great thanks to all the organizers for providing such a great platform. So as we have been discussing artificial intelligence in medical field, so I would be discussing a few depth about our field, that is dermatology. How can AI be useful for dermatology? Yeah. AI in medicine. In general, as in medicine, AI is defined as scientific understanding of mechanisms that are underlying thought and intelligent behavior and their embodiment in machines. AI always works in collaboration with human resources and the data we provide. So main applications in medicine can be, as we have already discussed, in radiology, pathology, and dermatology as well. So all ranges from automated blood pressures and robotic surgeries. So there's a wide range. So coming over to dermatology, AI has been playing a growing interplay between digitalization, telehealth, and informatics. Like in dermatology, there are several applications like distinguishing between malignant and benign lesions. As you know, in dermatology, there are many kinds of skin cancers that are very, difficult to diagnose, and they've been laid for years and years because of no proper diagnosis, no proper investigations, and in the remote areas, there are not even such awareness among the patients. So if we collaborate with AI for diagnosis of skin cancers using application of dermoscopes and some non-dermoscopic devices as well, so it can be very helpful. In 2017, a study was done at Stanford University for deep learning of skin tumors using AI. They used many lakhs of images of more than 2,000 different diseases, and they tested it versus 21 board certified dermatologists. And they then verified it with the biopsy reporting as well. And at the end of the study, the results of CNN AI were found comparable with the board certified dermatologist. And in identifying and classifying skin cancers, it was at par with the board certified dermatologist. For example, like there is a benign skin lesion that is non-spreading, non-cancerous, as compared to a malignant cancer. It is very difficult to diagnose at a place or at a setup where no proper facility is available. So in that case, AI can be very helpful. It can work over, photo recognition of algorithms and numeric values. And in recent years, there are many smartphone applications that are recently available for diagnosis of melanoma. We are also using a few devices that collaborate with our smartphones. They get attached to the camera of our mobile phone, and then we can just click a picture of the skin lesion. And on our phone, it is related. It is just linked with the app. On our phone, we get all the detailed, information about the lesions, how deep it is, how wide is it, and what are all the characteristics of the skin lesion. So it becomes very handy and very easy in diagnosing many skin disorders, especially skin cancers. Next, please. In ulcer assessment, there are many ulcers. Patients come with varied forms of ulcers. Few may be cancerous, few may be non-cancerous, few may be infectious, gangrenous, and many types of pressure ulcers, diabetic ulcers, and all. So AI is helpful. It would be really helpful in assessing the ulcer also. Once we are able to assess the boundaries of the ulcer, the depth of the ulcer, and for any malignant changes into the ulcer. So in that case, also AI would be very helpful. Psoriasis and some other inflammatory diseases. There are some inflammatory diseases in which AI can help in predicting, the therapy pattern of the patient, like which biologics would help in that particular patient. And we can also predict the quality of patient. There's a life scale quality of patient that improves or degrades along with the severity of disease. So assessing the skin lesions, assessing the response to the medicines, we can always predict the how will be the outcome of the disease, how is the life quality index of the patient deteriorating or not, and we can always plan the treatment accordingly. Other applications in dermatology can be like acne, grading acne, and lichen planus, pityriasis, acanthoides, dermatomyositis. These are various dermatological disorders, along with the melasma. That is a very common skin disease that we see, is pigmentation. In common language, people call it jhaiya, jo face par, they see black spots on the face. That's in common term, they call it jhaiya. So it's not just a simple term like pigmentation is there. It is invaried. When we go into depth, we assess it through dermoscopes, and as I discussed, the mobile applications that we are currently using, we can go into the depth, and we can predict the prognosis of the patient. Like if it's epidermal, that is the superficial, and if it whether it's dermal, that is deeper. So treatment and prognosis would vary according to the depth, and by looking at just naked eye, we cannot predict whether it's epidermal or dermal melasma, or it is a mixed kind. Accordingly, patient can be counseled. If it's deep dermal, you need not go for wasting your money, and there would be no much effect. But if it is a mixed kind of or a epidermal type of, if we get to know the diagnosis, proper layering of the pigmentation, like up to which depth of skin is that pigmentation present. So at the first sitting only, at the first go, we can advise the patient like how long your treatment would be, what would be your prognosis, and how much you need to go in for it. Otherwise, if we don't get the depth, the exact depth by naked eye, we cannot predict whether it's dermal, epidermal, or how will be the prognosis of that particular case be. Next, please. Atopic dermatitis, it is a very common dermatitis seen in adults as well as children. So in this also, artificial neural networks would be very helpful in differentiating them from other skin disorders that mimic atopic dermatitis. There are many other disorders that mimic, clinically they mimic atopic dermatitis. So that would be really helpful in differentiating. Onychomycosis, that is nail fungal infection. In that also, with deep AI learning, we can get comprehensive details about the nail involvement, how depth, up to till how depth the nail bed is involved, and how much is the fungus growth under the nail. So that would be really helpful with possible images. And predicting skin sensitization substances. There are some physiochemical properties of some substances that are present in some medicines and some skin products, some sunscreens, soaps, lotions that we give. So it would be really helpful in detecting which patient would be sensitized to which component of the prescribed medicine for topical application, or some sunscreen is given. Suppose a patient is given a steroid or any topical cream application, they carry some vehicles. With every medicinal cream, there are some vehicles and adjuvants and preservatives. So we never know patient would react to which substance. So in that case also, sensitization techniques would be really helpful with AI. Dermatopathology again is histopathology. We take a piece from the patient's skin lesion and we send it for biopsy and histopathology for detecting various for the diagnosis of all the major skin disorders which have been confusing clinically, and for diagnosing skin malignancies, whether it's benign or malignant, or their staging. In that also, AI can be really helpful. Next, please. Teledermatology, as in this COVID era, as you all know, we have been doing a lot of teledermatology, and in all the fields, not just dermatology, in all the fields, telemedicine and teleconsultation have been really prevalent in these last 2 years. So AI can be integrated with smartphone applications to photograph. For our specialty, it can be linked to the photographic skin lesions. Relevant skin clinical information can be asked depending on the skin lesion picture. To the patient, there should be there would be a subset of clinical questions like history of the patient and symptom symptomology, etc., depending on the skin lesion. AI would on their own ask the patients like what all symptoms you have, what all medicines you have applied, all the clinical information regarding the specific skin lesion. And then referral can be generated. Augmenting face-to-face assessment as well. AI and dermatologists have been working together to achieve better results in diagnosing and managing many complicated skin conditions. AI can be used as an educational tool also for dermatologists, researchers, students, and skin cancer specialists. For, after going through a series of many visually similar images, experts are able to gain deeper insights into their cases. In that case, also AI can be really helpful in educating young students and researchers. Next, please. A few limitations that we think would be there, and there's nothing that cannot be, covered up. In near future, I really hope all of these limitations would be covered up by our technology. Main is generalizability, like in Western world and from our developed nations, all the studies are there regarding the relation between dermatology and AI, but not in developing nations. So findings are applicable to the rest of the world. In our skin disorders, the skin lesion for a particular disease, the way it will be, visually visible, clinically visible in a Western country or in a Caucasian patient as compared to an Indian patient or a dark skin patient, it will be very different. A same diagnosis would be very different according to the skin color it is on. So all the data, all the pictures and all the, pictorial information for skin disorders have been from Western world, but not from Indian skin point of view. The diseases would be really different clinically as compared to the Western point of view. So image quality is also a limitation due to technical variations and differences in image acquisition. Image quality can affect interpretation and diagnosis and further prognosis, management, everything. So another is that I would think is data, a large barrier. Prerequisite for large data is developing a processed algorithm for AI. The image data of skin disorders should be, in depth and covering all the racial populations. Interpretability, AI is flexible in forms of algorithms, reevaluates, and constantly brings changes without human input by means of neural networks. Therefore, at times, logic behind the decision making may not be interpretable. As we have already discussed, they cannot replace doctors completely. They just work as our helper or assistant, or just making a task easier. But completely, AI cannot replace the medical field. Next. Acceptance by patients, a proper history followed by examination and specific signs complemented by additional investigation or biopsy. This is the standard way of diagnosing in dermatology. First, we examine the patient, we take the specific signs, and we take the history of clinical features. Then, if required, we go for investigations or skin biopsy. So this holistic approach cannot be fully replaced by any methods of AI for sure, but AI can be really helpful in early diagnosis. Like we can, as we discussed, merging it with teledermatology, the app, the moment patient sends a picture, our work of taking the history, clinical signs would be, limited by AI. AI would its own ask all the clinical features and history according to the picture of the skin lesion. So our work would be basically reduced to just investigation, biopsy, and diagnosis. So liability and ethical issues, obviously, and varied disorders. Like dermatology is a very, very vast branch, very many variations in every disorder. So to recognize a few skin lesions, and whereas the dermatological condition is extremely varied, it would be really difficult to diagnose specific skin lesions at times because of vast variations. So AI can identify and classify in a broad term, but further specific diagnosis and further investigation and all has to be done by doctor itself. But it would be a really helping hand and a big time saver for doctors. Next, please. conclusion is that the diagnosis and classification of skin diseases required comprehensive consideration, as we discussed. Patient history, gender, age, clinical features, investigations, etc. beyond photographs. Most of the data is based on Western studies. As we know, the skin lesions of the same disorder, same diagnosis as to Western countries and comparison with Indian patients would be really different in view. And the way a Western patient skin lesion would look, a Caucasian patient skin lesion would look, and the same disease when on Indian skin would look completely different. So the data is right now from European and Western countries as only. Studies from this part of the world are also essential for incorporating pictorial data of Indian and ethnicity skin also. AI is advancing field for hence a basic knowledge about fundamental principles, potential uses and limitations. It all becomes very, very important. So that's it. Any questions are most welcome.
Great. Thank you so much, Dr. Singh. We'll be addressing all the questions during our panel session, which is going to start in just a few minutes. In the meantime, I would like to invite Dr. Bhanwar Ranwa. He's currently the head of Department of Cardiology at the Government Medical College in Kota, Rajasthan. So am I audible?
Yes, ma'am.
Okay, great. Welcome to the session, sir. So can you please unmute yourself?
Host has made me mute, madam.
Okay.
I was unmute, possibly you did it.
Okay.
Am I audible?
Yes, yes, sir. You are audible, sir. So what we kind of wanted to hear from you was, the challenges that are present in cardiology in general, and perhaps those that we can address, with the availability of data.
Okay, thank you. First of all, I'm sorry for being late, and thanks to the organizer for this wonderful opportunity to interact with the enormous people with different backgrounds and share our views as far as AI is concerned in cardiology. So first I would like to state that as you know, I am dealing with something that is a non-communicable disease. In disease system, two kinds of diseases are there. One is communicable, that can be communicated from one person to person or by vector or by someone else to the other. And second kind of diseases are non-communicable diseases. What does that means is that cannot be communicated from one person to other person directly or indirectly by some vector. Vector is a sender. So we are dealing with cardiology, cardiac diseases, and you know that prior to the age of 60 years, the biggest killer in the world is cardiac diseases. And India, the sad news is that India is the capital of cardiac diseases in the world. Likewise, diabetes, obesity, every non-communicable disease we are harboring in our country. And on top of that, the diseases, some people will say these are the diseases of modern civilization. Some used to say these are the diseases of prosperity. सेठों की बीमारी है जो लोग उसमें रहते हैं, मतलब मान लीजिए आपके शहरी सेटअप में है, those who have left their physical activities and developed the diseases. Like we are earning a lot, everybody is earning, दिमाग बहुत चलता है लेकिन शरीर नहीं चल रहा, हम बैठे ही रहते हैं, केवल दिमाग चलाते रहते हैं. So that's when we start landing into the diseases of this is modern world, man-made diseases, non-communicable diseases, and disease of the riches. This is the disease of riches, but nowadays it is percolating into the poor also, because we have a good as far as the instruments, modern technology is coming, so we have stopped using our hands and food. That's why this is the India is a capital of these man-made diseases these days. I am a man of that field who is dealing with all these diseases. Now what comes, since we know cardiovascular diseases are the biggest killer even in the young and middle-aged women, middle-aged category. After the age of 70 years, cancer is the biggest killer worldwide, prior to 70 is the cardiac diseases is the biggest killer. So question comes, how come artificial intelligence help us, guide us, and improve our knowledge and help us to disseminate our knowledge to the masses so that it can be communicated in a good manner, the disease can be curtailed, or it at least it can be hold on for the time being. Anything when we learn in medicine is that there are 4 stages of any disease. One is 4 stages of disease, how some disease starts in a society. Like first is the primordial stage. What happens prior to this prior to the full blown non-communicable disease, we develop start developing risk factors of the disease. Likewise, cardiac disease is the full blown disease. Prior to that there are risk factors which are there in the society. You can stop the disease there in the society where it starts. How? That is known as the primordial prevention. Prevention of the disease prior to the risk factors development in the society. I'll explain with an example. Like obesity is one of the cause of, or sedentary lifestyle is one of the cause of cardiac disease. Now sedentary lifestyle nowadays begins at the age of 5 years. बच्चा 2 साल 3 साल 4 साल तक खेलता है, उसके बाद में वो कंप्यूटर पकड़ लेता है, फिर वो मोबाइल पे बैठा रहता है. द टाइम sedentary lifestyle begins. Now by the age of 18 years he is fully into this sedentary lifestyle, and at the age of 18 years you go and see that is the fellow is obese, he cannot move much more. आप उसको कहेंगे दौड़ेंगे तो दौड़ने की जरूरत नहीं भाई, इस मोबाइल से देख लेंगे. So by the age of 25 years, he is a cardiac patient. So what we need to stop is that percolating the message of not using their physical activities is bad. That is primordial prevention. Now, second stage is primary prevention. What is primary prevention? Obesity has set in. Now, obesity should not terminate into the cardiac disease. Then you will have to say the people, say the man, he just start running, get your diets controlled, eat properly and sleep properly. That is primary prevention. Third stage in the disease comes, we started at the primordial prevention. Obesity should not develop. We got obesity. Now we are asking people, you are obese, but please don't go ahead. Try to stop it over here or get some your weight lost. That is the second stage. Third stage, patient, the man cannot stop this obesity, not control and get back to the normal sizes. Then we say, now you are in a full-blown disease era. Then comes the cardiac disease. At this stage, how artificial intelligence can help us? Early diagnosis of the disease. Like you are a risk factor person, you have this problems with you. Now please stop at here, and otherwise you will be a cardiac patient. That the time artificial intelligence can help you. Now the man didn't stop here, वो आगे फिर से चला जा रहा है, वैसे ही खाया जा रहा है. Then he comes with the acute myocardial infarction, acute coronary syndrome, acute heart attack. Still we can guide him with the help of these people, these softwares and everything. Now you had an MI, you had an heart attack. This is the severity of this disease. Minor है, major है. What is the prognosis? Now what are the treatment options left with you? That can be told to him. And in the last, when you are done with everything, then you can prognosticate the disease. Like this was the disease, you had this much of infarction, you had this much of your heart muscles lost. What are the chances in the future getting this disease back? What are the chances of suffering with some complication of this disease? All these propensity based models, what we call in medicine is propensity based models. Way back, these all the things were running in the on the data which were stored in the general surveys. Like out of 100 people who had cardiac disease, you in like 1950s, 50% of them would die. In 1970s, what happened? 30 people of them would die. In 1990s, 220% people died. Like now we are running in 2020 and so So we say anybody who gets an cardiac disease or acute heart attack, 10% or 5% of them are supposed to die. Now, how artificial intelligence can help? These softwares run in the system starting from the 1950s. What were the disease incidents? कितनी बीमारी होती थी, उसमें से कितने मर जाते थे? How the treatments improved? By the treatment, how the mortality got down? And in the future, if the treatment options improve, what are the chances of someone getting a heart attack and being live after the event? These things can tell us. These things can also tell us somebody who has got a heart attack, like this we call as genetics and progeny. Someone had an high cholesterol levels, he died at 40, 50 years. Now the siblings comes to the physician. They ask, what are the chances of me getting that disease, me dying of that disease, and how can I stop it? These intelligence-based models, they have sophisticated softwares. They will tell these are the chances, like 20%, 30%, you are likely to get a disease. What are the chances of the age you will get a disease? What are the chances if you get the disease will be this so much of the same severity of your parent, or it will be of less clinical implication? How can you stop in earlier days? This is how these machines and artificial intelligence comes into play. Like we are, I think rather than diagnosing the patient, artificial intelligence should be used and must be used in a broad perspective for the masses. How it can be used for the masses? Based on these systems, there must be some software, some data developed, and government system should indulge with these people, and they should forecast a society map. Artificial intelligence can develop a social map of the cardiac diseases to the population. Likewise, I think the leader of the state should announce, we have this much of the population, these are the diseases running with us, these are the chances. The people, young population who are the workforce, manpower, everybody is saying we are the capital of young people in the world. So we should also warn them, we are the capital of the diseases also in the world. Now the man-made diseases which are running, which are going, which are flourishing, which are going to be a blasting like situation in our country, the way we are running, the physical inactivity, drugs, and a lot many things, abuses and everything is which is going on. The state leaders should come, and they will tell us how can the artificial intelligence system will tell us, we have this much of the working population. You say earning population, somebody says workforce, this is our workforce. What are the chances of this workforce getting diseased with some serious illness and landing them into incapacitated state for life, like 10%, 20%? Then how the vacant places will be filled by one who can work it and find out the solution for it. So artificial intelligence, rather I think they should these things must be used for the masses, and that has to incorporate the private sector with the government systems. At least at the end of the day, I think the government is responsible, the rulers are responsible for the bad or good of the society.
I think that is an excellent point that you are making, that the data that is available kind of has to be shared between different entities. And so if you don't mind, since we're kind of running a little bit short on time, I'd like to open this question up to the panel discussion. A couple of our panelists actually had to leave because they're I know they we understand all medical professionals and researchers have really busy schedules going on. So with that, I think this is a great question that we have. The availability of data is essentially what is powering artificial intelligence. And so any existence of a platform that can, provide the data between different entities, between industries, researchers, and medical professionals is something that becomes of key importance. I think this is an excellent point, sir.
Yes, I think I am done, mostly done. My assertion is that industry people and government setups should collaborate and find out something like we should give the projects and direction to the masses.
Agreed, sir. Agreed. With this, I would like to invite our panelists to please unmute themselves so that we can kind of have a discussion on some of the questions that have been asked in our chat box, as well as a few other questions that we have. Data availability is, of course, one of the biggest challenges that I think AI developers face is the lack of availability, lack of easy access to that data. Dr. Bohra mentioned that the data exists, but actually getting it into a digitized form is where the challenge is. So I would like to ask Professor Rajesh and Mr. Aryan Singh to kind of elaborate on the challenges that we face with data in terms of preparing these applications.
Yeah, so
Yes, sir.
can I start?
Yes, sir.
Okay. Few things are very important when we are working with these things, and many of the speakers today also highlighted those things. We need to study, we need to think of the IT policies. We need to see how our medical system is working on. How about the consents of the sharing of the data? Are there any kind of mechanism being developed? I'm not sure of that. Maybe medical people could comment on that. Are there, what type of permissions patients they put in to share their data, and then once these two things are okay, then how to secure those data, because it's not a very naive idea to put the data on a common platforms for the ML people to jump into it and do whatever they want to it, because they affect a lot of things in the future also. So we need to think in a complete kind of things, that how these issues which are related to the healthcare data, they are being connected and they are being made like secured, so that can be used properly. Yeah.
That's a fair.
Aryan, you want to add to it?
Yes, so when it comes to data ethics, we have to maintain utmost. Am I muted? Not okay.
No, we can hear
When
you.
it comes to data ethics, we have to take care of the utmost and the topmost data security. We have to follow all those data security protocols. We have to keep the data anonymous as long as the identity of patients is not required. There has to be proper consent and it has to be legalized. All of this has to be legalized. The government has to step in. That's there. So that's on the back end. And I think us on the front end, we can take care of the digitization of the data. So when we talk of data digitization, there are models which are very good at this. They're getting good performance. So we worked on one model with Mashreq Bank in Dubai, and we've also been exploring other applications when it comes to document intelligence. So there are many applications, but when we talk of how to get it done, there are these models that parse the layout of a document. So if we upload a medical report, even if it's handwritten, it would be able to tell, okay, this section is this section is the name of the doctor, this is the topmost section, this section is where all the medicines are prescribed, this section is where the data of the patient is written, such as weight, etc., blah, blah, blah. And we can parse the layout, and then we can categorically, there's this model which is going to read handwritten characters, and then we're going to use natural language processing to fit that into a schema. Now we have to figure out a schema for these digital medical records. So we can call it Health ID. And I would love to get started on building such a thing over here and have it be a global movement, because I've seen even in America and other places, people are getting started with it, but nobody has a force to properly implement it. We have the technology to take care of security, we have blockchain, and we have artificial intelligence to help us with the digitization of this data. And those are the things that we have to figure out and get started with. I think if we start experimenting, if medical institutions, they open up to the digitization of data, Of course, we need to be very careful with data ethics, with consent, and all of the legal data parameters that are important, and we will take care of them. And then we should start working on these models, the different models that digitize data, and then we organize this data, and then we can start working on getting insights from this data, and then making models on this data so that some things can come out of it.
I think Professor Rajesh Kumar and Mr. Aryan Singh both make an excellent point. I think where we are headed here is something related to what Dr. Apoorva Singh said, is the patient trust. I think when we talk about data in general, we talk about all the clinical reports and everything, but what would be the perception of the general population when they find out that their data is being digitized in such a manner? And I think that is something that maybe as developers of this tech, we kind of have to consider as well.
Yes, very much so. So I have seen in other trials, some experiments that MIT and Boston was conducting. They were using patient data which was anonymous. So it has no linkage with the patient. It had no identification factor. That's one policy. Even then, they had a consent form. And so, yeah, consent is very much required. It has to be there. And for many models, the data can be anonymous for the training and the developing of machine learning models. And when it comes to patient-driven applications, such as making health ID or the categorization of all the records and having the connect between patient and doctors and having the personalized medicine factor, then we need patient ID. But there can be such models that patients sign up for. So if we start experimenting with pilot projects and with a small test batch, we can show how effective it can be in our applications over here, and then patients can sign up for it.
One point I would like to make, as far as data secrecy is concerned, madam. Basically, मुझे ये लगता है कि गवर्नमेंट नोज एवरीथिंग. देखिए मैं आपको बताता हूँ कैसे है. सालों से पोस्ट फ्रीडम any disease in the area where health system, peripheral health system driven by the government setup is there. So the record of every disease is made. Like ना आज से 50 साल पहले भी आप जहाँ रहते थे वहाँ पे कोई हुआ था, आप अस्पताल में दिखाने गए, वो रजिस्टर में दर्ज है, वो हर चीज रजिस्टर्ड है, सब तो गवर्नमेंट के पास में है. Now to use this data for the welfare of the public or to use in other way, that makes some difference. Government knows everything. These are the data like how many people are suffering with anemia, with low hemoglobins, I would say. खून की कमी से कितने लोग सफरिंग कर रहे हैं, वहाँ पे सबको गवर्नमेंट को पता है. डायबिटिक्स कितने हैं उनके सेटअप में, कितने जो दिल की बीमारी के मरीज हैं, जो आपका न्यूरो की मरीज है, तो गवर्नमेंट नोज एवरीथिंग. This is the point. There is a collaboration which is needed between the officials of both the systems. How this data can be used for the betterment of the what is to be done, the way is to be made out of this. Thank you.
Very much so, Dr. Bhura.
Here I put it a different opinion. Everything is with the government, it's okay. But if I'm a private player who is handling with these things, and a lot of things are affected out there, they depend on it. I don't allow why people are taking my data. We have a lot of cases. Forget about healthcare, it is very sensitive. Even social media platform, these data are very, people are using in some good way or bad way. Healthcare data, some informations are there, but it is not like it is for any kind of a public platform to use it. If I can manipulate the things, I can manipulate the data. I can manipulate the things with your life insurance policies. I can do a lot of things with the data. So privacy, IT policy, because see, we know all these things are happening in the world. We know IT policies, we know machine learning methods, algorithms, model, whatever we can say. We have data, but they should be integrated. We know blockchain, we know security, these things we know. But right now, there is nothing like a complete solution. and that is the most, that is very sensitive issue. Unless until we have a complete some kind of a complete regulations from the board, government body, some kind of those things, these things may create a bad effect also when it moves into the masses like that.
You are right, but what I mean to say is that when someone goes to some government setup for some medical help, so it is imperative, it is thought, it is bound कि वो अपना वो that is a service sector. तो वो आपको वो अपना इंफॉर्मेशन वो दे आर बाउंड टू हैव दिस. वो आपको नर्स वो दर्ज भी करेगी कि भाई ये मरीज आया था, इस बीमारी से आया, तो रिकॉर्ड्स आर देयर. अब ये सही है आपकी बात कि वेदर टू यूज दिस डाटा फॉर everybody has got some private thing and everything, that must not be used. That is the point I am asking. There should be some way to use this data for the welfare of the society. I am not asking कि भी आप कैसे करें. How come these data can be used to develop AI based models, so we can guide the grassroots workers will have an ideas कि भाई इस तरह से आप ये काम करोगे तो इतने दिन बाद में आपको ये बीमारी हो जाएगी, इतने दिन बाद में इससे बड़ी बीमारी आएगी, इतने दिन बाद में आप मर जाओगे, तुम्हारी औलाद को ये होने वाला है, उसको ये होने वाला है. तो so the grassroots worker, those who are in direct contact with the person in the village, in the remotest of the areas, so the people will, those grassroots worker will help them to not to develop the disease. If they develop how to get it rid of and treat it in time. This is the thing. That's why we need a collaboration, and everybody will have to work. Definitely.
Sir, another point.
Privacy is an issue. Thank you.
Sir, another point is in this, as Dr. Bhanwar said, data तो already store हो रहा है. जैसे उन्होंने कहा कि 50 years का data आपको मिल जाएगा. The data is already being stored. If we introduce technology, we can have blockchain and smart contracts, and then the data becomes mathematically immutable. So if we introduce something, it would be better than the existing policy, first of all, even when it comes to the privacy and the security of the data. Point number one. Point number two, India and such areas, tropical regions, we have a lot of population, and the problem that there are medical professionals are not available in remote areas, in villages, and a lot of places. We need to use AI maximally so that we can treat patients over there. In remote areas and in rural areas, many patients die because of the non-availability of medical experts. And I think we should use AI so that data, we should use all of this data to make models that help those patients. And these models again would not replace doctors. It can they can better connect.
Yes, sorry to interrupt you in between. Our motives and doctors, our cardiac expert motives are okay. We need to think what are the issues. Everybody want to provide a solution. The issues are this, unless until these bodies like medical councils and all these people, they put the things in a proper way, we can have a very bad impacts also. So that is my urgent worry. See, you are a good in blockchain, you can make it secure, but we must have certain policies first that, okay, how to handle these things, and then we can jump into it to get the things good for.
Basically, what we're getting at is we kind of need more, I guess, a centralized guidelines kind of that would govern this process.
Yeah, see,
Aryan, I would like to add to this discussion. The thing is, data is not a bigger issue as perspective of AI, because already we have set ethical guideline for data uses from medical sciences or hospitals and all. Either it's from private hospital or it's from government hospital. The need of R is to collaborate. Suppose some of the hospital or any of the organization, not only the hospital, is not sharing their data. But if that particular organization agreed for collaborations, then we can easily use that data with their ethical guidelines and all. So I think the first thing is to collaborate. और जितने भी research हैं AI पे अभी, so they already use hospital data with some collaborations and all. And even some of the people don't need to collaborate, because many of the hospitals are working good with advanced technology like AI and all. So even they can use their own data. And it, yeah, yes, Dr.
Dr.
Kumar.
Ravi, Dr.
Yeah,
Ravi, can I share my experience with you?
yeah, sure, sure.
It took me 1.5 years to
One
get
minute, just 1 minute. Let me
a,
complete. There are lots of ethical issues associated to data. Nobody can deny this. Even I have some good and bad experience. Some
uh-huh,
people deny to
uh-huh.
collaborate, and some people are. But the thing is, the only solution what I can or we can do it collaborations. Collaboration make it easy for data sharing or even the technology transfer and all things. Better please, Dr. Kumar, you share your
Yeah,
experience.
so what I'm putting here is the data which we are taking is only in the physical sites and all that. It took me around 1.5 years to get a medical ethical approval from the board itself. By
That's
that
I
time, the things
understand
are gone.
that I
See, this is a
understand.
common case. What I'm sharing with you, this is a
Yeah,
common means like doctors are here, they are in the board of ethical committees and all. It is not very easy in India. You can go and try to collaborate, but when you talk about okay ethical approvals and all these things, one
that
year just for a pass of one application, that to be the surface mounted sensors, nothing more than that. So things are there. We need to check on these things, these issues, that how to make these issues first, so that the accessibility of the sharing of the data is there. Then we have experts who collaborate with each other and they put the things in for the common purpose. What is the goal of all the doctors and the technocrats?
right, right.
Or we can run pilot projects.
Yeah. And one more challenge is sometimes data is not in appropriate way that can be used by some advanced technology like AI or for some specific task, like some data is missing some informations. Suppose patient data is missing exact age or exact geographical location and all. So this is another challenge for data kind of issues. And obviously, a proper guideline of local government, or you can say the global policy makers, is must be needed for any collaborations at the point of data exchange.
I think the discussion on data is something that is so huge when it comes to
Yeah,
medical
sure.
profession by itself, because every test has a large number of data that is generated, and it's difficult to get that digitized. And then with AI professionals, it is absolutely necessary to have access to that data, and since it is analyzed in depth by a third person, there have to be ethical guidelines that do kind of govern that. But of course, there has to be a collaboration between government bodies, and researchers and industries. And that is basically the goal of what we are doing here today, is to open those channels and to kind of, communicate the kind of data that we do require, and get in touch with each other and get working with each other to, implement artificial intelligence applications in healthcare. I'm going to direct the question a little bit, my next question a little bit towards everybody. Actually, we had one of our participants actually asked this question in the chat box as well, but their question was, how can COVID-19 be detected with artificial intelligence? But I'm going to also add a second question to this, which is basically, we, with vaccinations going on all over the world, we keep hearing about, herd immunity and everything. So what factors would be important in predicting herd immunity? And now this is kind of a question that is open for everybody, because we need to hear about this from medical professionals as well as AI developers as well.
Let's go one by one. So the first thing was, what can we do about COVID? So we were working with a team and us and Rajesh. So we were working together, TensaX Innovation Lab and Rajesh sir's Raman Lab. And we had a proprietary data set of chest X-ray scans. And we worked towards early screening. So it wasn't quite early screening, but it was something like, when you have a patient and you don't know how severe the case is, how do you identify how much attention to pay to them? So when you do your RT-PCR scan, it takes a few hours. You have to get the blood distilled, and then it takes a few hours for it to be processed although doctors understand this part much better than I do, but there wasn't a way to quickly find out how severe the case was. So when you do a chest X-ray scan, you can look at the opacities and grade the opacities. The X-ray machines, these X-ray machines are available everywhere, even in remote areas. The one machine learning model can grade these images and identify how many chest opacities a person has, and that's a clear indicator of how severe a case is when it comes to COVID. And so that we can identify whether this person needs to be kept in an ICU or somewhere else, or how they would respond. The other way of getting it is we get the CR value, which is how affected that person is. That's one application. And when it comes to herd immunity, I don't understand the biology side of it. Doctors can comment much better on this, which would be, what are the factors that we would need to look at to predict how we can identify when we have herd immunity? Would it be the number of infections? Would we need to work with pathologists? We worked with Dr. Bilal and their lab, and we looked at a lot of pathology data, and we looked at how, first of all, how we can predict, let's say a person has gotten a blood test and they have 14 blood parameters. How can we predict the 15th blood parameter based on 14 parameters? And then we were also looking at, in epidemiology, how we can identify hot zones where diseases are, where there are more cases of diseases, and how can we identify trends and patterns when it comes to demographic data, and what sort of trends and insight we can derive from that. And maybe we could predict where the next malaria hot zone could be, or in terms of COVID, if we look at all of those data points, we could earlier predict how quickly it would spread. But now that it has spread already, we should look at how we can predict herd immunity, so that we can take a better call on how to open up COVID restrictions and how to proceed further on. So we can maybe talk of what factors would be relevant when it comes to predicting herd immunity and the biological side of it.
Can I add one point to Aryan?
Hmm.
What he said likewise, someone of having COVID disease, you get an X-ray done and you find some opacities, whether it's an X-ray or CT scan. Now what happens? There are 10 radiographers. मान लीजिए आपके इलाके में 20 radiographers हैं. You know only 20 radiographers only. So someone says this is a CT score of 5, some say 6, some anyone other one says 10, 12. What AI will do? AI has a data worldwide, all experts, whatever the scans has been done, and what are the chances of someone telling this much of the score of getting right. So you will have कहीं भी जगह भी रिमोटेस्ट ऑफ द एरिया में अगर आप रह रहे हैं, आपको आप एक एक्सपर्ट से ओपिनियन लेंगे, दूसरे से लेंगे, आपको एआई तो ये बताएगी हम आपको दुनिया भर का एक्सपर्ट का ओपिनियन दे रहे हैं, एंड दैट विल बी द मोस्ट एक्यूरेट डाटा टू डायग्नोज द डिजीज. लाइक मैं कोई बीमारी का कहता हूँ, मुझसे कोई मरीज मिलता है कि तेरे को दिल की बीमारी होने के चांसेस 50% है. दिस इज माय सिंगल ओपिनियन that has born out of my experience of the patients and my intelligence and my work. Okay, but these people know the data of more than 1,000 and lakhs of the people of my kind. So see the accuracy they will have. Yes. The point is that it is to be used in the right context. Like अमेरिकन फाइल्स जो थी, वो सारी केबल्स वगैरह अमेरिका की आर्मी के पास में थी, वो असांज ने कैसे यूज की वो एक अलग मैटर है भाई. उसने कैसे यूज किया, क्या एक्सपोज हुआ, कोई पता नहीं. वो तो गवर्नमेंट तो अपना सिस्टम चला रही थी ना. तो राइट वे टू यूज द डाटा, डेफिनेटली डाटा हेल्प्स. लाइक आप करें कि उसकी प्राइवेसी एक्सपोज हो जाता है, ये हो जाता है. हम तो ये देंगे ना, आपको ये बताइए ये एरिया, जैसे इन्होंने ये कहा सेकंड पॉइंट आर्यन मेड कि व्हाट आर द हॉट जोन्स. सम chances of someone getting the disease with the same X-ray may be 0, with the same X-ray may be 90, more than 90% also, depending upon is the disease running in this area or not. If the disease is running in that area at that point of time, because the chest opacity, the X-ray opacity might be due to thousands of the causes. Yeah. But at that point of time, if the disease is running, that software will tell you probably this is the disease and this is the severity of the disease. Now march upon the disease, work accordingly, you will get the best results. This is the system how it is to be used. अब दूसरा कोई उसमें से निकाल के लगाता है कि कल तेरे को टीबी हुई थी, 5 साल बाद मैं बताऊंगा आपकी इंश्योरेंस से पहले टीबी थी, तेरे को क्लेम नहीं मिलूंगा, वो दैट इज द सिस्टम। समाज में लोग किस चीज को कैसे कैसे यूज करते हैं, वो दैट इज द डिफरेंट। बट आई थिंक दिस AI बेस्ड सिस्टम मैक्सिममली व्हाट दे कैन हेल्प ना इज द रिमोटेस्ट ऑफ द एरिया।
Yes.
शहर में तो जरूरत ही नहीं है, थोड़ी सी घबराहट होती है हमारे पास आ जाता है कि साहब घबराहट हुई, हम रोजाना ECG कर रहे हैं, उसको फिर करें भाई बीमारी नहीं है घर चल जा, बोलने साहब घबराहट हुई, दोबारा ECG करा रहा है, तीसरे दिन करा रहा है। मुद्दा ये है कि समवन हैड एन कोरोनरी इवेंट 5 days बैक, स्टिल वो ये सोच रहा है मेरे को गैस की बीमारी है, उसकी हेल्प करनी है आपको। सॉरी टू से आई एम टॉकिंग इन माई कंटेक्स्ट ओनली। तो आपका ये बेस्ड सिस्टम, इवन दो जो वहाँ का ये अगर टेक्नोलॉजी रिमोटेस्ट एरिया में, इवन दैट पर्सन और वुमन माइट नॉट बी, जो हेल्थ केयर वर्कर है उतना स्मार्ट नहीं है, उतना इंटेलिजेंट नहीं है, उसको पता नहीं है, लेकिन उसको ऐसा कुछ सिस्टम से ये पता चल जाए कि भाई नहीं ये डेंजरस फेलो है, शिफ्ट हिम, refer him to somewhere better center as early as you can help him. That's why you will save somebody's life. So that is the point. We need to percolate these things to the poorest of the areas. Thank you.
Very much so, exactly. And we have many regions in this world, including India, Africa, and other places, where the availability of experts isn't there, and there are no resources for setting up hospitals and setting up specialists everywhere, which is one of the biggest reasons why we need to make these models. And I think we should do whatever we can do in our capacity. We can run pilot projects, we can have a consent form for patients, and then we can collaborate and see on what points we can collaborate. We can see and study the workflow of the different diagnoses, and see what models we can come up with. And this is a relatively new space. We have all the expertise, and if we come up with something worthwhile, maybe it can go very big. It can turn out helping a lot of people and also be something worthwhile building. And Dr. Bhura, regarding the earlier comments you mentioned, those were two different projects. The chest opacities project was different. Over there we were working on COVID data, and the same is true with other types of opacities as well when it comes to pneumonia or anything else. And what we were in talks with Dr. Bilal, and what we did over there was we were looking at the data of blood test results for epidemiology. And I think now we can, even after this conference, we can set up meetings and talk about all of the different ways in which we can make something. And we can have a framework and a mechanism to do that. Doctors can tell us about their workflows, the types of data they work with, and then we can think about what types of models we can come up with. These models are not very hard to build. We've built a variety of models, and those same mechanisms apply in healthcare. So within a matter of weeks, we can get something out. If we can throw around ideas and we find something has its need, we can experiment with it. And yeah, that's all.
Okay, that's nice. Can I put a bad picture of it? Because being academia, my job is to put those things in these platforms. Our cardio expert, he told a very true story what is happening. If I think all of us have seen last 2 years, there are a lot of claims in newspapers that okay, we have X-ray images and our AI is giving 100% solution and we are expert of it. Now you no need to do anything, just have X-ray and then we can detect it. Not only here, across whole of the world. And then I start following the research articles. A lot of publications are there. And now the challenge what Aryan is speaking, they say, no, there is a very closeness in X-ray about COVID or some lung infection. So the things changes. Now people are jumping on it. And then what our cardio expert is saying that, okay, you have an X-ray, 0% chances, another X-ray, 100% chances. So that is basically really a major issue, because healthcare is something very sensitive, one part. Second, In AI, since it is not a very complex, it's a mathematical, and two people jumped into it. They get the software algorithms from the net and they just implement it and reach to the conclusion. And that is where my concern and should be the means like proposal from this through this conference, unless until we have both the doctors and AI experts both on the same driving seat, don't claim for those things and all those issues, because these things will result into, because see, even we are working on these images, but right today what Dr. Cardio expert said, that same X-ray may have 100% chance of C19 or may not have, but though who will give these inputs? Just not only by just analyzing one feature of it, we cannot say that okay, we reach to a complete solution of it. And what is happening in today's world, in the name of AI, people are selling everything. So we have to be very careful, and that is basically my comment on the things.
So we're not going there right now. We're talking about let's say in a rural area, our model is not 100% accurate. It is, let's say, 87% accurate. Now, if you apply that model to how many numbers we have in India, we have millions, lakhs, tens of lakhs of patients who need to be screened. And as Dr. Bhanwar said, that they don't know, they think that it's some other disease and that disease doesn't even get screened. Now, even if at an accuracy percentage of 87%, applied to lakhs of people, and there can be some misclassifications, but at 87% too, if we deploy such models, look at how drastic of a change we can bring over there.
Yeah, Aryan, that is my major concern. Even a one wrong diagnosis is dangerous. That is my major concern, because the remote person, he cannot reach to the doctor. We can reach to the doctor, unless until we are our models are very accurate and a lot of information.
In the beginning, let's not focus on replacing. Nobody ever is replacing doctors. So we are talking of models that can refer patients to doctors, even in different applications. Let's say even in dermatology, a doctor can have their own app, and their own app takes care of the patient's acne. And if the acne gets severe, the model classifies it and it's recommended to the doctor. So it can be better in terms of like the workflow of sending patients. We're not, the AI model wouldn't directly take over the entire process. It can recommend those patients to doctors. It can screen those patients, and those patients who would have thought that it's some other disease, those patients would be identified, and then those patients in remote areas can be referred to doctors who are experts, and no matter where they are, we would know how many patients are suffering from a particular case. Also, sir, another point, we may be thinking that yes, of course it is a tedious process, but technologically, mathematically, it's doable. We have the latest research papers, and these models are very easily deployable on smartphones, as well as specialized healthcare equipment, whether it comes to handheld retinal scanners. When we were working on diabetic retinopathy with Dr. Maya, we had explored this, and my very dear friend who owns US Ophthalmic, they are a US-based supplier of handheld retinal scanners. They had embedded the model in their handheld retinal scanner, and these low-cost retinal scanners could be deployed in villages across many spaces. So running it on hardware, whether on the cloud or mobile devices, it's a tedious task, but it's doable. We've done that, and it is doable. And also, I think it's a question of when rather than why, because for us to cater to a population that's that big, let's say us having our own models that is taking care and helping thousands and millions of people, and that through that route, it's recommending all of those patients to expert doctors, then that could help us set up a great working workflow in within the whole healthcare cycle. So it's a question of when rather than why. It would happen. Now the thing is whether it comes from America or it comes from India, that's the question.
Aryan, sorry to interrupt you. These are not my observations. My observations are on something else. I'm not saying we are replacing the doctors. My observations are there that most of time I have seen in articles, research article of very good journals, the findings they are proposing it only based upon the information they have, which are not very correct. Helping the again we are missing the main issue, main concern. We are moving towards helping the people, doing all these things. Okay, that is good. We need to do it because our population is big and we need to provide a solution. Only the concern is there are a lot of people who are not contacting the doctor. They are gathering the information, the data from somewhere, taking the algorithms from somewhere, and then they are coming out with the proposals that these are the findings. That is my concern, not nothing on any of other things. I hope you understand. You take my point in that.
Yes, sir. We're on the same page.
I think we are actually talking about the same thing in that, the data that we have, the results that we provide, they do need to have a medical insight as well, a confirmation of what, whatever model that we have used, the diagnosis is correct or the treatment is correct. That kind of has to still be verified by a medical professional. And that is, I think, the biggest bridge that we have to kind of understand is that artificial intelligence is not about, just giving, it's not just a model that's just going to give us an output. There have to be knowledgeable people who stand with it and kind of provide guidance on whether it is correct or, it needs improvement. And, all of this has to be taken care very sensitively, of course, because it is a matter of life and death for a lot of people who are going through these algorithms. So I think all of us are actually talking about something that is approaching the same point in different ways. So I think this has been a great question. We do have a couple more questions. One of them has been essentially how artificial intelligence-based medical systems can be, made available to the people in general. I think as these projects, are very expensive when we talk in terms of finance. So I think part of the answer that lies is in terms of the applications that already exist, like, really easily accessible apps.
So I think when it comes to deploying these models can run on end user devices, or these models can run on the cloud, and then it can be covered. When it comes to the development costs, they are not that expensive to build. We built the world's highest performing facial microexpression recognition model here at the lab. We took 65,000 images and we trained a model on that, and it was a multi-parameter classification. So it's one of the more complex models. It took us 4 months to build that. Obviously, the results initially were much better, and then the fine tunings and fine tunings, it took that time. So one training cycle usually took 3 days on one of our systems, which has a graphics card. So it is doable on for a lot of applications. Like when we talk of cardiology, the data is one-dimensional. The rhythm of the heart, it's one-dimensional data. When we talk of photos or videos, those are two-dimensional. Images are two-dimensional arrays. When we talk of some other type of data, MRI and others, topography scans, those are three-dimensional scans. So it can get complex, but it's still in the same ballpark of in the doable range. It is doable if we find the right, and to mitigate the questions that we have from this point and to mitigate the issues that we earlier mentioned, I think a close collaboration of technologists and doctors is imminently required and imminently desirable. And I think we can sometime, we should set up meetings on how we can get further in all of these specialized fields. And something that's other than these specialized fields is are the orchestration tools, tools that help with digitization, tools that help connect doctors with patients and manage the whole thing, making virtual assistants, and how we can start to test them and how we can start to implement them. And of course, it's in the larger sense, it's about building the ecosystem that will build the future of all of these technologies, because sooner or later we will see them, and people are already working on them. Our space if we talk of India, requires it more than any other place, I believe, because of the resources that we have and the amount of the complexity in cases and the number of cases we're dealing with. So we can and should make use of all and the smartest ways to approach the problem, so that in the amount of resources we have, which is plenty to solve the problem, we can get the best results and good results.
I think that's a really good point. Since we're running a little short on time, we're already over our time by quite a bit. We're going to take one last question that's in the chat box, and I feel like this is a very specific question for Dr. Vikram Bhura, who actually had to leave. He had an emergency at the hospital, so he actually had to leave the session. The question is, for dementia in artificial intelligence, can AI help in assisting informal caregivers, families or non-professionals, on caring for an elderly with dementia in their households? So I was able to actually get the question to Dr. Bohra, and his response is very simply, it can help to, that artificial intelligence can help to identify potential reaction of a given patient with respect to his needs, or even interpret patient's action, if the patient is unable to communicate as such or by action, then that way it will become a bit easier for the caregivers to manage their patients. And that is something that can be done for this specific question. So what I'm going to kind of request all of our participants and our panelists as well is that if you have any other questions for our panelists or questions in general, please mail them to us at business@tensax.com, and we'll be sure to connect with our panelists and get these answers posted on our website and our social media. So I know this discussion has been quite invigorating, and it's brought about a lot of different ideas, regarding what needs to happen from the medical professional side as well as from the technologist side to kind of, collaborate and work together. And I hope we can, come up with something, continue this conversation offline as well, and get some research projects going, some collaboration going where, artificial intelligence in healthcare applications can be developed. So at this point, I would actually really like to thank all of our speakers and panelists here, Dr. Bhanwar Ranwa, Dr. Apoorva Singh, Professor Rajesh Kumar, Dr. Vikram Bhura, and Dr. Ravi Ranjan Kumar Neeraj, for joining us today and sharing their valuable thoughts with us, and discussing all of this and providing all of this great information to all of us. So thank you so much, everyone.
Thank you.
Thank you so much, everyone. It was great to interact with all of you today. And thank you so much for sharing your thoughts and your experience in your domains of competence. And we'd love to talk to you after the event to talk about and start building on how we can get started on building these things here, and how we can explore the different applications, and how when we find something worthwhile, how can we start testing it and seeing its results. So we look forward to talking to you later, and we look forward to learning about your workflows and how do you get your tasks, and where all AI applies in those tasks, and how when we take care of technology, how you can lead such a revolution in your sectors in healthcare. And I believe those would be great conversations from now on. And thank you all of you for being here. It was so great to have this conference today.
Thanks all.
Thank you, everyone. All right, with that, I'd like to close this session. And thank you again for joining us. If you have any questions, just email us, and the recording for this session will be available on our YouTube channels, or you can follow us on our social media pages. I have added those links to our chat box, and the video will be available there as well. Again, thank you so much for joining us today.